guys. So today we're going to learn about algebraic fraction. This is actually just the continuation of the topic of algebra from grade 7. When you were in grade 7, you have learned the basics of algebra, for example, like simplifying expression and also solving equation. And today we're going to learn about that again, but this times we're going to have fractions on those expression or that equation. Okay, so let's just start. So when we're talking about fractions, a lot of things that you need to understand first before we go to the algebraic fraction here. So let's start from a very simple um, fraction concept that we have learned also when you were at primary school and also when you were in grade 7. For example, if I have something like 4a over 6, for example, we can actually like it's not 4a over 6, it should be like 4 over 6. This can be simplified as 2 over 3, right? Because as you know that both of the numerator and the denominator are divisible by 2, or you can actually write it down like this, guys. So 4 over 6 is actually is like 2 times 2, and it is 2 times 3. And you can see that because they're all being multiplied, so we can do cancellation here. So we can cancel the 2 over here. Sorry, it should be that, right? So we can cancel some numbers like this. Okay, so it's just like 2 over 3, and we get the same exact answer. Okay, so when we go to algebraic fraction, it's actually the same thing, and the same concept applies with that if you want to simplify some fraction. And maybe the focus for algebraic fraction here is where you have fractions in algebra, and you have also an arithmetic operation. For example, if I have like x over 2 plus 3x over 2. So this has the same concept when you are adding a fraction. For example, if I have like 3 over 4 plus let's say it's 5 over 4, right? So this is just 8 over 4, because we know that we can just like add the numerator because the denominator are the same. If they're not the same, then we need to make them the same. Remember the topic about equivalent fraction, that is also going to work. For example, if I have like 2 over 3 plus 3 over 5, in here when we add or subtract fraction, we need to make sure that the denominator are the same first, then we can add the numerator. So how can we make them the same? With actually you just find the LCM of 3 and 5. For this case is 15, right? So I'm gonna write down 15 over here. Okay, so convert these two fractions so that into their equivalent fractions, so that the denominator is equals to 15. Can you see that going from 3 to 15 is you multiply this by 5, right? So 3 times 5 equals to 15. So whatever you do on the denominator, we do the same exact thing with the numerator. You multiply that by 5. 2 times 5 is 10, and then we have this one here, the equivalent fraction of 3 over 5, where the denominator of 15 is you go to 5 to 15, you multiply that by 3, so which means that the numerator also multiply by 3, and you'll get 9. And just like do, because you now have the same exact denominator, then you can add them together. 10 plus 9 is equals to 19 over, so you can 19 over 15. Okay, so for this one you can actually simplify that. 8 divided by 4 is equals to 2. Okay, so this concept will be very important for you guys to understand. Okay, so now let's go to the example of algebraic fraction, in which they have one operation here, which is addition. Okay, so let's start here. So again, what you need to do first, if you want to add or subtract fraction, you need to make sure that the denominator are the same. And here, the denominator are exactly the same, right? So which means that we can just add x plus 3x, right? So which is going to be 4x, right? So the denominator doesn't change. Okay, so make sure that you don't change the denominator. Okay, guys, after you get the same denominator, don't change it. Your final answer should be the denominator should be equals to 2. So in here we can actually simplify. For x divided by 2, you can cancel the 4 and the 2, right? Because both of them are divisible by 2, or have the same factor, which is 2. Divide this by 2, you get 1. Divide this by 2, you get 2. So you'll get equals to 2x. Another example, if I have for example 2x over 3, and then add that with 3x over 5. And again, this is an addition. The first thing I need to do is to make sure that the denominator are the same. If they're not the same, then find the LCM of those denominator in here, which is 3 and 5, which is the LCM is going to be 15. So make that so both of them have the same exact denominator. In here we know that we go to 3 to 15, you multiply that by 5. You do the same thing with the numerator. For that fraction, that will be 10x. Okay, remember we have x in here, so 2x times 5 is 10x. Okay, the next one is 5 to 15, you multiply that by 3, so you also need to multiply this by 3. 3x times 3 is equals to 9x, and then you only need to add the numerator since you have the exact same denominator. So that would be 10x plus 9x, that would be 19x over 15. So just make sure that the final answer should be in the simplest form of fraction. So well, you don't have to change this into mixed fraction. Just leave it like this. Okay, so the next example, maybe let's say I'm gonna show you another method actually. For example, if I have like 2x over 3 and then plus 4 over x in here, what if we have what do you call it, the denominator as a variable, for example like this. Okay, 2x over 3 plus 4 over x. So we can actually do what we call a cross multiplication, I think. We can do something like this. So you multiply this with this one first, and then you will get equals to 2x times x is 2x squared, and then you multiply this with this, right? Because this is addition, so it's 3 times 4, which is plus 12 in here, and then the last one is just 3 times x, which is just 3x. So 3 times x comes from here. Okay, so actually this is the final result. So you can actually do the same thing when we have this question here, right? So I'm going to show you. Okay, let's do the same exact question again, but this time we're going to use this concept, this method. So we have 2x over 3 plus 3x over 5. We're going to cross multiply that. We have 5 times 2x, which is going to be equals to 10x, right? And then we have 3 times 3x is positive, right? So it's plus 9x, and then the next one is to multiply these two denominator, and that will be just 15. As you can see, that 10x plus 9x in here will be equals to 19x over 15. Can you see that we have the same exact answer? So you can actually use this concept. Okay, so maybe I'm gonna give you one last example of adding or subtracting algebraic fraction. So let's say I have now 4 over 5x plus 3 over 2x. So I'm gonna use the concept that we just learned here, but remember that after you get the final answer, you should make sure that that is the simplest form of fraction. Okay, if it's fraction. If it's not, it's the simplest form of the answer, like integers or something. Okay, so let's do that. So we are going to multiply 2x times 4, then you will get 4, sorry, it's 8x, and then the next one is 5x times 3. Okay guys, so maybe I'm gonna change this into subtraction. Okay, so that will be 5x times minus 3. Okay guys, so the what do you call it, the 15x in here, so this is minus, right? So this is subtraction, so subtracting here, and then you get 5x times 2x, that will be 10x squared. Okay, don't remember that x times x in here will be x squared. Okay, so the next one is that we can just like subtract these two values here, those two terms, because they are like terms. So 8x minus 15x is equals to minus 7x, and then over 10x squared. But this isn't over yet, guys, because actually we can have these two as something like this. So I haven't taught you about exponent yet, but this is how we do it. So this is how the concept works. So 7x means 7 times x, right? So minus 7x, right? And then 10x squared is actually like 10 times x. Remember, if we have a multiplication, we can just cancel, for example, because we know that both of the numerator and the denominator, both of them have the same factor, which is x. So we can cancel one x over here, one of them, yeah, just one. Because just, yeah, okay, that will be equals to what's left is just 7 over 10x. Okay, so this is the addition or subtraction of fraction. Let's go to the next operation, which is a multiplication. So another example, guys, if I have like 3a over 5 multiplied by, sorry guys, I'm gonna use the multiplication sign like this because it's not x is like this. Okay, this is how I write it down to make a difference between x and x. Okay, multiply that by, for example, like 2bc over 9a. So this is actually gonna be easy because this is just a multiplication. When you have a multiplication of fraction, you can cancel anything that are the same. I'm like the factors that are the same. So I'm gonna use that factoring concept like this, guys. So we have 3a and 9a here. Actually, like let's say a first. I'm gonna cancel the a. Remember that what you can cancel is numerator and denominator, so it must be paired. So you cannot have like numerator and then you cancel it. No, you cannot do that. Okay, so it needs to be paired from the denominator and the numerator. Okay, the next one, I'm gonna cancel the 3 and the 9, so divide both by 3. I get 1 over here and I get 3 over here. Okay, so we cannot cancel anything else, so which means that we can just like multiply 1 times 2bc, though that just be 2bc, right? And then on the denominator, we have 5 multiplied by 3, which is equals to 15. So this is going to be the final answer, right? Quite easy. The same thing with division. Remember when we have for example, like 15ab over 14, let's say it's a c, divided by let's say it's 35a over um 28, for example, 28 cd, for example. Okay, so remember that when we have a fraction divided by another fraction, so we can actually change this sign into a multiplication sign, and then you swap the numerator and denominator. So we can rewrite this question as 15ab over 14c multiplied by 28 cd over 35a. Can you see that I'm just swapping this one so that this goes up and then this goes down, and then change the division sign into multiplication sign? Okay, so we do the same thing like we did before over here, right, where we can cancel a lot of things here. So I'm gonna cancel from the number first, maybe. So we have 15 and 35, divide both by 5. You'll get this is 3 and this is 7, and then I'm gonna cancel this also with this one, divide both by 7, you get 1, and then we get 4 over here, and we can cancel this one and this one, divide both by 2, you get 2 and 7. Okay, I'm done. We're done for the numbers here. So let's go to the variables. In here we have a and a. Remember, it needs to be on the top and bottom. So we have a on the top over here and over here, and we have c over here and over here. Okay, so we don't have anything else to cancel anymore, so just multiply all of them, what's left in there. So we have 3 times b times 2 times d, so that would be 6bd. And then on the bottom here we only have this guy, 7 times 1, which is equals to 7. That's it. Okay, quite easy. Another example, guys, so maybe this is going to be the last example for addition and subtraction. We have, like, for example, like 2a plus 3 over 5, and then subtract that by 3a minus 4 over let's say it's 2. Okay, so again, guys, you can do the cross multiplication like we just did before. I'm going to use that concept again, guys. So I'm going to multiply this with this guy, right? So remember that for this one, because you have like more than one terms like this, you need to put that in the bracket first and then you expand them. Okay, so if you have this, you will get 2 times 2a plus 3, right? This 2 comes from here, right? And then this 2a plus 3 comes from here. Okay, so the same thing with the 5 and the 3a minus 4. And here, remember, pay close attention to this sign over here. It's a negative sign. I mean, like, it's a subtraction. So which means that you're going to write it down like this. It's going to be minus, right? So minus over here first, and then you write down 5. Like this 5, and then you write down in the bracket all of these. Okay, so you multiply that with 3a minus 4. Okay, the last one is you multiply the denominator, which is equals to 10. 5 times 2 equals to 10. Okay, now what we should do first is to expand the bracket here. So 2 times 2a is going to be 4a, and then 2 times 3 is going to be 6. Remember that you need to write down the a plus sign here. And then the next one is, this one is, you need to be very careful because this is like minus 5. So you're going to multiply a negative number with the one inside the bracket. Negative 5 times 3a is negative 15a. And then negative 5 multiplied by negative 4 is going to be plus. Okay, so going to be added with 20. Okay, be careful with that. And then the last one is going to be 10 on the bottom here. Okay, so we can see that we have like terms here. Sorry guys, I have different color. No problem. We got 4a and then minus 15a, and 4a added with minus 15a is going to be minus 11a, and then 6 added with 20, you'll get plus 26. And then this guy doesn't change, so that's going to be the final answer. Okay. Okay, next up, we have some question again about simplifying fractions. So simplifying fractions. Okay, so again, involving algebra, for instance, if I have like 2a plus 2 over a plus 1, so you might think of okay, because both of them like had this, so we cannot cancel anything, right? We cannot cancel this. No, don't do that because it won't work. So we can actually do something like this. When you are in grade 7, you learn about how to factorize, right? So we can see that this expression here, we can actually factorize that expression. So that will be equals to 2 multiplied by a plus 1, right? So remember, when you are expanded bracket, you multiply like this, right? So 2 times a is 2a, and then 2 times 1 is 2, right? So you go back actually here, right? So we can again factorize that. After you factorize, you can see that I'm gonna write down again the one and the numerator. So I can just like actually put some brackets in here because that's actually just 1 times this, right? So you don't have to do anything with the 1 in front. So we can actually here see that these two terms are being multiplied, right? So 2 multiplied by all of these, and then this is like 1 times all of these. So because we have the same exact factors in here, so we can just cancel them. So cancel the a plus 1, right? And then that will be equals to 2 over 1. So actually we have 1 over here, but you don't actually need to write it down. So this is just 2 over 1, and then that'll be just equals to 2, right? Okay, so another example. Let's say I have 3a plus 9 over 2a plus 6, right? So again, guys, you cannot cancel the a directly like this. Please don't do that. Okay, so because we still have like an addition here, so and we have they're not they're not being multiplied. Okay, so please don't do that. Okay, so the first thing that you need to do first, again, you need to factorize, right? So 3a plus 9, we can factorize that as 3 in the bracket a plus 3, right? The same thing goes with the denominator. We can actually also factorize this, so you get 2 in the bracket a plus 3. Can you see that we have the same exact factors now, right? Although I say you cannot add them because it's addition in here, because this is also an addition, but this one here is inside the bracket, exactly the same thing. So this is actually just like 3 multiplied by this and 2 multiplied by this thing, right? So because they are exactly the same, so you can cancel them. They're the same factor, so that will be just equals to 3 over 2. Okay, So next question, next example is involving a quadratic expression. If I say like a squared plus 5a plus 6 over a plus 2. Okay, again guys, do not cancel like this, do not do that. Okay, so that's going to be incorrect. So in here we can actually do again the factorization. If you don't know how to do this, please see the videos that I have about factoring. I will put the link description below later on. Okay, so this can be factorized as a plus 2 times a plus 3. Okay, the one on the denominator doesn't change, but I'm gonna use a bracket this time because we can actually like, oh, this is just like 1 times this. Okay, so in here guys, you can see that again we have the same exact factors, right? Exactly the same factors. Then we can cancel them, right? So what's left in here is just a plus 3. So you can open the bracket because there's nothing else outside the bracket. Okay, so and then one more example maybe for the quadratic. We have a squared plus 7a plus 12 over a plus 4. Right, the same thing again, guys. You can factorize this expression, quadratic expression. Maybe I'm gonna repeat the concept a little bit. So you are going to focus here and here. If the variables of variable square has a coefficient of 1, this is how you do it. Okay, so you're going to be focusing on these two numbers. What you need to think of that if you multiply two numbers, you have two numbers, right? We have two numbers. If you multiply, you get this number here, and if you add them, you will get this number, right? What pairs of number can have this result? Okay, so which means that if I have, for example, if I have 12, multiply two numbers by 12, for example, like 6 times 2. 6 times 2 is equals to 12, right? But if I add 6 with 2, you will get equals to 8. This is not 8, right? So these two numbers are not the pairs that we're going to use to factorize this algebraic expression. So instead, we're going to use other numbers. For example, 12 can also be the product can also be the result of the multiplication of two numbers, which are 4 and 3, is it, right? 4 times 3 is equals to 12, and 4 plus 3 is equals to 7, right? Oh, okay, so because that works, means that we're going to use 4 and 3. Okay, so, which means that we can factorize this as a plus 3 and a plus 4. You can actually swap them around. For example, this is a plus 4 and this is a plus 3. It doesn't really matter because they're actually being multiplied. The same concept if I say what 3 times 2 is equals to 6, 2 times 3 is also equals to 6, right? So you can put them whatever you want in front or on the back. Okay, so the same goes here with the denominator. It's a plus 4. Again, I'm going to use a bracket this time to make sure that for you to understand that this is like in one whole. This one and this one are the same exact thing, the same exact factors. Okay, so we can cancel those two, so that will be just equals to a plus 3. Okay, maybe one more example. The last one. Yeah, the last one for today. This time I have a quadratic on the top, on the numerator, and also in the denominator. I have a squared plus 9a plus 18 over a squared plus 11a plus 30. Okay, so that will be equals to what? Okay, again, guys, do not cancel like this. Do not do that. That is completely wrong. Okay, so you need to factorize them first so that they're being multiplied and the same factor can be canceled. Okay, so in here again we're going to think of two numbers that if you multiply you get 18, if you add you get 9. So the answer are 6 and 3, or 3 and 6. So we can factorize this as a plus 3 and then a plus 6. Okay, the same thing goes here. You multiply two numbers, you get 30, and then if you add those two numbers, you get 11. That will be 5 and 6, right? So that will be a plus 5 times a plus 6. So I'm gonna write down like this time. It's the same thing, and the same exact thing, guys. If you see the same exact factor for this one, which are these two, right? They are exactly the same. They are factors and exactly the same. They're being multiplied, right? So which means that we can cancel those two factors, and then what's left is just a plus 3 on the top and a plus 5 on the bottom over here. Okay, the last subtopic for algebraic fraction is to solve algebraic equation. Okay, so if you want to solve, for example, so basically again, guys, it's just like the same thing like we have learned in grade 7. For example, if I have 2a plus 5 equals to 17, right? And then you want to solve this, solve for the value of a. So how can we do this? The basic concept is to make that variable alone in one side of the equal sign. So we have this equal sign over here, right? So that a is on the left side, right? This a is on the left side of the equal sign. So what we need to do is the goals is to make that alone in that side. So what we need to do is to get rid of these two things, right? So the concept is just do some operation like addition, subtraction, multiplication, division, and maybe some index or roots, right? So that the variables alone in one side. So we're gonna do it like this, guys. So we're going to focus on the addition first. I'm gonna focus here first. So how can we get rid of that? We can get rid of that by subtracting it by 5, because 5 minus 5 is equals to 0. It's gone, right? It's just 0, right? Anything plus 0 is the same exact number. So like 1 plus 0 is just 1, 2 plus 0 is equals to 1, so on, so on, so on. And then one more concept that you need to understand, that every time you do something on the left side of the equal sign, you do the exact same thing on the right side of the equal sign. So I'm going to write down that equation again. We have 2a plus 5 and 17. So I'm going to subtract both sides by 5, right? So we need to be fair. The left side, you minus 5, right side also minus 5. So what happened here is that this is gone, right? Plus 5 minus 5 is just 0, which means that what's left on the left side is just the 2a. So I'm going to write that 2a over here. It's gone. So 17 minus 5, this one becomes 12, because 17 minus 5 is 12. And the last thing is that we need to get rid of this guy over here, that 2. So 2a means 2 multiplied by a, right? So what we need to do is to do the opposite operation of multiplication like we did over here, right? Because this is addition. So you do the opposite operation of addition, which is subtraction, right? So to make it gone. The same thing here, guys. So this guy here, 2a, is 2 multiplied by a. So what you need to do is to divide this by 2, right? Again, both sides do the same thing. And you can cancel, right? 2a divided by 2 is just a, or 1a. You can just cancel this. And what's left on the left side is equals to a. 12 minus 2 divided by 2 is equals to 6. And then you're done here, because the a now, the variable, is alone in one side of the equal sign. So this is the concept, okay, guys? So what happened in algebraic fraction is actually the same exact thing, right? For example, if I have algebraic fraction, let's say I have again solve this equation, for example, like 2a plus 5 over 4 equals to 3. Okay, so again, the basic concept is to make the variable alone in one side of the equal sign. So this one has a on it, right? So we need to get rid of this, this, and this, right? Okay, so the easiest way to do this, guys, if you have a fraction, the easiest way is to get rid of the fraction first. I mean, like the denominator first, okay? And here the denominator is this guy, right? So it's being divided by 4. So you do the opposite operation of a division, which is multiplication. So I'm going to rewrite that again. 4 and then equals to 3. So I'm going to multiply both sides by 4, exactly by 4, right? So if I do that, I can cancel this, right? Because it's just a multiplication. So what's left on the left side, we only have 2a plus 5 on the left side, and then on the right side we have 12. And then we do the same exact thing like we did before over here, right? The same exact thing. So it's just different value, this different number. Okay, so we do it again. So it's like subtracting both sides by 5, right? And it's subtracting, sorry, so plus 5. Subtract both sides by 5. And then you get on the left side, you only have 2a, because this is gone. Plus 5 minus 5 is just 0. 12 minus 5a is equals to 7. And then divide both sides by 2, right? So 2a divided by 2 is just a. And then 7 over 3 is just 7 over 2. Or if you want to write it down as a decimal, that will be 3.5. Okay, that's the basic concept. Okay, another example. What if we have something like this? We have 3a over 2 plus 2a over 5 equals to 4. Okay, so like we just learned previously on how to simplify algebraic fraction if you have like addition like this guy. So we just now let's just focus on the left side of the equal sign first, okay, before we go to this guy, right? Because that's just alone on the right side of the equal sign. So let's do that. Let's simplify this operation first, and by using, for example, like the cross multiplication. So if I multiply this with this one, I will get 15a, and then if I multiply with this one, I will get 4a plus 4a, and then if I multiply these two, I'll get a 10a, right? Just 10, sorry. Doesn't have any. 2 times 5 is just 10. Okay, so that will be equals to 4, right? So again, in here, we can just like add these two numbers here, the two terms, and which is going to be 19a over 10 equals to 4, right? And then we go back again here, right, to the previous example, right? So we can solve this as 19a over 10 equals to 4 by multiplying both sides by 10. Remember, guys, if you have a fraction like this, the easiest way to do it is to get rid of the denominator first. Okay, that's one of the easiest way. I mean, like, yeah, the shortest way. Okay, so we can cancel the 10, right? So that leaves the on the left side I only have like 90a. On the right side I have 4 times 10, which is equals to 40. And the last thing that we need to do is to divide both sides by 19 to get rid of this 19, because 19 divided by 19 is just 1, right? So 1 times a is just a, and then 40 over 19, you don't have to write it down as a decimal. If this is the simplest form of fraction, then you are done. Okay, so if you understand the concept, I would like you to try these four questions. Number 1 and 2, just simplify the algebraic fractions. And for number 3 and 4 is to solve algebraic equation involving fraction. Okay,